All right, we're back. A couple more area questions. This one was just like a little bit of a kind of a sticky wicket here. It's like there's a path and a rectangular garden. So I'm going to draw a rectangle. Maybe this is the garden, 12 by 20. Sure, let's say that. And then I'm going to have another rectangle that looks something like this. That's not perfect, but it's doable. Looks a little better. So the deal here is we have a garden and a path around it. And so it says the garden is 20 by 12. So this is 20 by 12. And then there's a path around it. And like this distance here is 2 meters. And this distance here is also 2 meters. And this distance here, also 2 meters. And this distance here, it's like 2 meters all the way around. So it's a nice garden with a nice wide path for strolling. The question is find the area of the path, just the path. There's a couple ways to do this. You could like cut this thing up into like different rectangles. That's a way to do it. But I think maybe a little bit easier way to do it is to figure out, to realize that there's an inner rectangle and an outer rectangle, and the difference between their areas is the area of the path. So the area of the inner rectangle, just like every rectangle, is base times height. The base is 20 because it's the same as this one. The height is 12. So it's 20 times 12, which is 240. Area of the outer is a little trickier, but not much. I need the base, which is this whole distance here. I know that from here to here is 20. Then each one of these is 2. So it's like 2 plus 20 plus 2. So the base is 24. And then the height, well, I know this height is 12. I know that each one of these little distances here, this and this, those are each 2. So it's 2 plus 12 plus 2, which is 16. And 24 times 16, of course, is 384. And the area of the path is the difference between those. It's the difference between the outer and the inner rectangles, which is 384 minus 240, which is 144 meters squared. This time I have to do the unit because it told me meters and meters. And I know that area is measured in distance squared, not just distance. And now we move on to the next couple problems. Then we'll save this one for class time. This one's kind of hard. So the base of the triangle is 1/2 the height. The area is 64 square centimeters. Find the base and the height. Okay. So the base is half the height, which means it's taller than it is wide. I'm just going to draw some triangle. I don't know what it looks like. Like this is B, and this is H. And the area of every triangle is 1/2 times the base times the height. They tell me that the area is 64, so I can write 64 equals 1/2 base times height. But since I don't know either of these, I can't solve this. There's like a million different answers, a literal infinity of answers to this for B and H, the way it's written. So I got to narrow it down. And this sentence gives me what I need to narrow it down. The base is 1/2 the height is equivalent to saying the base is 1/2 the height. B equals 1/2 H. Base is half the height. So what that means is instead of writing a B in this equation, this is like a system of equations, which we studied before. I can replace that B right here with 1/2 H. That's what I'm going to do. So instead of writing B here, I'm going to write 1/2 H. I'm going to rewrite everything else. B equals 1/2. And now instead of B, I'm writing 1/2 H, still multiplied, times 1/2 H, and then times H. So just to restate, the thing that I replaced here was this. I took the B and I replaced it with 1/2 H. I left the 1/2 here and the H there. Everything else is the same. And now I do some math. So 1/2 times 1/2 is 1/4. and h times h is h squared. So I get 64 is 1/4 h squared. My thinking is to get the h by itself, I should multiply both sides of this thing by 4. Multiply the whole equation by 4. So 4 times 64 is 256. 4 times 1/4 is 1. That was the whole point of this. And 1 times h squared is just h squared. I take square roots of both sides, I get h equals 16. Technically plus or minus 16, but since I'm talking about distances here, I'm going to use the positive one. I get h is 16 centimeters. So that's h. And I can find the base by just using this little relationship I have here. If b is 1/2 h, and h is 16, then b is half of 16, which means b is 8 centimeters. That's supposed to say times 16. Let me rewrite that. So I get b is 1/2 times 16, which means b is 8 centimeters. This is my answer. 16 for the height and 8 for the base. And that's it. All right, last thing. I kind of like this one because you have to use trig, and we haven't done that yet. So find the area of the triangle. So to find the area of a triangle, I need the base and the height in general. And they give me the base is 42, and the height's got to be from the top of the triangle straight down to the base. This is h. I don't know what it is, but maybe you can see that there's a right triangle right here. This side is something less than 42, this side is 31, and this side is h. And I know this angle. And since this is a right triangle, I can use my right triangle trig relationship, which says that the sine of this angle is h over 31. Sine is opposite over hypotenuse. Sine opposite hypotenuse. So I can write the sine of 26 is the opposite side h over the hypotenuse 31, which means that h multiply both sides by 31 is 31 times the sine of 26. So I can plug everything I know into my little area equation and get the answer. 1/2 times the base of the triangle, which is 42, times the height, which is 31, times the sine of 26. I can just punch all this into my calculator at once. 0.5 times 42 times 31 times the sine of 26. Make sure you're in degree mode or it's not going to work. And I get 285.380. 285.380 once it's rounded to the nearest thousandth as was requested. And there's no units here, so I can just leave it like this, and that's my answer. So we can use trig sometimes to find the heights or bases of these things if we need to. And that's often what you have to do. So now you know how to do that. And we'll talk about this more in class. Bye.